Okay, so today we're going to look at restricting the domain, the x values of these graphs, basically looking at part of some graphs. All right, so let's look at an example. So 1a, let's say our function f of x equals x squared. Let's say this is our graph. So we're going to look at a parabola that opens up. Where's the vertex of this parabola?
0, 0.
0, 0. It doesn't go left or right. This is the parent graph, right? Doesn't go left or right. Doesn't go up or down. We're at 0, 0. It opens up. So we know what this looks like. We know what this looks like. All right. So let's say I want you to graph f of x if the domain is restricted to just x is bigger than -3. So I want to graph that parabola, which we all know what it looks like, but only if where the domain is bigger than -3. Okay, and I'll show you how to do that. Well, what's good about the homework is it'll kind of set you up to do this. So at -3, this parabola, if we look at it like this, you don't even have to draw this, but you can just kind of look. So we know what the graph looks like. And this is what we're doing in general. If I ask you to graph this, every single person in here can graph this. Y equals x squared, we just go, oh, it looks like this. It's right there at 0, 0. It opens up. Perfect. There is our entire graph. But what we're going to do is we just want to see this when x is bigger than -3. So -1, -2, -3, it's right there. And actually, it's just a open circle because it's just greater than. And if I just cover that up, that's actually what we want. From -3 on, that's the part of the graph we want to see. Okay, does that make sense? Okay, so, but we just need to be a little bit more accurate because at -3, we need to know where that is, where it starts. Because we're going to actually draw this with our pencil. We need to actually put our pencil down somewhere and then start going. Okay, so they're going to prompt you. And so they'll say, hey, what's f of -3? Because that's kind of where we start on this. So what is f of -3? 9. So -3 squared is 9. Okay, so 9. Actually, Chrissy, you shut the door, please. Thanks. Awesome. Okay, so -3, 9. All right, so let's go ahead and graph this piecewise. So let's draw this, thank you. All right, so -1, -2, -3. And I'm going to put 9 up there. That. Okay, so -3, 9. And I just want it when it's just greater than. So there's no equal sign, so it's just greater than. So I put an open circle at -3, 9. There we go. And we want it when x is greater than, right? Opens up to the bigger. So when x is greater than this. So we want to see the graph on this side. All right, so I could just graph the entire parabola like this. Okay, but I'm not. I'm just going to start from there, and I know it's this right here. So this is my parabola. We could all graph that, but I just want to see it when it's from -3 on. Okay? So that's it. That's what it looks like. Okay? Does that kind of make sense? All right. Okay, so let me do domain and range as well. So domain, what is our domain? Because this is good review for the quiz. -3 curved, yes. -3 all the way to infinity. Good. Range of heights, what's our lowest point? Y equals 0. Is it a square bracket or curved? Squared, so it goes from 0 all the way up to positive infinity. We don't have to stop at 9. Good idea, because it's an open circle, but there is a 9 over there, so we're just smooth all the way through there. So there's our range. All right. Okay, let's look at another here. 1b. So same. We still have f of x equals x squared. Move this up. Okay, we want to graph this same graph. So graph the function if they only want when x is greater or equal to 2. Greater or equal to 2. All right, let's draw this. Draw this. And so let me just kind of back up. So when I give you this is just kind of random what I want to see. It's not any particular reason why I picked this. I could have said, well, let's graph this when it's bigger than -1 or bigger than 5, right? So this one, graph the function if x is bigger than or equal to 2. Okay, so it looks like this. Here's our regular parabola, y equals x squared. We just want to see kind of over here, this part, when it's bigger than 2. So we need to be able to put our pencil down somewhere and start this thing. So where do we start this thing? Well, they give you. So f of 2, we have to figure out where that is at. So what is f of 2? 4. Good. 2 squared is 4. So at 1, 2, 1, 2, 3, 4. Do I put a closed circle or open circle?
Closed.
Why closed?
Because
There you go. Equal to. Greater or equal to 2. So right there. All right. So we want to see this parabola when it's bigger than to the right of 2. Okay. So we're over here. One way you could possibly do this, and it's perfectly fine if you do it every single time or just the first few times, you can kind of forget this and just graph this entire thing. I like what I did up here. But you could do this. I'm going to do this lightly. So lightly do this. This is our parabola. We can every single one of us can graph this thing. So there's our entire parabola. But do we want to see this entire parabola? No. Where do we want to see the parabola? Just greater or equal to 2. So then you take your eraser and you erase all that like this. And so this is the only piece of that parabola. So it looks like there's probably a little more of a curve to it. You can kind of see that. So go ahead and graph it. That's it right there. That's the parabola when it's bigger or equal to 2. Okay. Let's do domain range. Okay, so what's the domain from 2 on? So 2 to infinity. Range is from, where is that at? 4 all the way to infinity. There you go. So there's domain and range. Okay. Okay, number 2. Okay. All right. So let's see. F of x equals negative parentheses x plus 1 squared plus 3. All right, so we got a parabola. It's not a parent graph, but it just shifted. No big deal. All right, so let's say I want you to graph. So graph f of x if x is just greater than -2. Okay, so let's draw this, -2. All right. So we're going to graph this parabola when we only want to see it when x is bigger than 2. I can almost guarantee you every single one of us can graph this. If I don't do any of that, we can all graph that because we know it. Does it open up or down? It opens down. So part of your picture should be part of a graph that opens down. Parabola opens down, and we know how it shifts, right? Okay. So, but just like the homework's going to have, it's going to help you here. So f of -2. So we need to know where to start our pencil. So f of -2. So plug that in. So -2 plus 1 is -2 plus 1, -1. Then what do we do? Then exponent, so square -1. So what's -1 squared? 1, and then times negative. So -1 plus 3 is 2. That's where we start. That's where we start. Okay, so negative 2, 2. Open circle or closed? Good. Open. When it's just greater than. So like that. All right. So here's a common mistake. Here's a common mistake. We go, okay, this is where it starts. We want it when it's bigger than negative 2, so over here. So, okay, so it's a parabola. It opens down because of negative, so we just do this. Just opens down like that. Or is that right? No. Well, why not? Okay, well, x is bigger than negative 2, so I do want this side. But we need it a little bit more accurate. Because I know it doesn't look like that. If I had you to graph this, it's not going to be quite like that. Where's the vertex? Negative 1, 3. So plot this. Negative 1, 1, 2, 3. It's up there. That's the vertex. Okay, so, and then actually just plug in 0. And so 0 is 1. So negative 1 plus 3 is 0, 2. So it's right there. And so our parabola actually goes kind of up, and then there we go. That's our graph. That's our graph. Okay, it's not just down there. Okay, so because literally we're taking a piece of the actual parabola. Okay, kind of makes sense? Okay. Fortunately or unfortunately, we're going to look at 4 more examples. So, all right, domain is from, okay, negative 2, and is it curved or squared? Curved. From negative 2 all the way to infinity. Range of heights is, okay, how do we write the range of heights? This is up at 1, 2, 3 is the highest. Good. Negative infinity, small to big, right? Negative infinity all the way up to 3. Square bracket? There is a height of 3. It's right there. So we include that. So it's closed. So square bracket. Okay? Okay, let's see. Number 3. Turn this over. Okay, 3. Okay, f of x equals 2x minus 1. Okay, this is a line. This is a line. All right, so we're going to graph this function f of x if x is less than or equal to 0. All right, well, we can do that. There we go. So we want to see this graph when x is less than or equal to 0. Okay, well, let's see. F of 0. Got to know where this thing starts. Okay, where's f of 0? So plug in 0 for x, and what do we get? Negative 1. All right. Is it, so it's a line with a slope. All right, slope of 2. So at negative 1, or 0 comma negative 1, 0, negative 1 right there. Here's our start. It's a closed circle because x is less than. All right, so there we go. All right, so we want to see this graph when x is less than or equal to 0. So I don't want to see anything on this side. So there's nothing over here. So our graph's going to be over here, right? Because it's when it's less than 0. This is our graph over here. So, well, how do we graph a line? Slope. Good. What's our slope? 2. So what should we do? Up 2 over 1. Up 2 over 1. And okay, and start drawing. What's wrong with that? I don't want to see it over here. Not a big deal, because the line goes on forever in both directions. So it's going to go this way. So if we want to do this somewhat accurately, we go down 2, left 1. Right? So down to, so it's like this. And there's our graph. That's it. That's it. Just going to make sure we have the right side. All right? Okay, domain range. Quick, just to do this over and over and over until we get it. But I think we're getting it. So the domain is, how do we write the domain? Negative infinity all the way to, what's the rightmost point? 0, including that. right? Range of heights, the lowest it is way down there to the highest it is -1. There you go, including that. There we go. Okay. Then 3 more. Okay, number 4. Okay, so bear with me here. All right, so we have exponential, 2 to the x minus 3. 2 to the x minus 3. Yeah. Can you wait? Emergency? Okay. Okay. All right. So we're going to graph this if we're from -1 less or equal to x less than 3. So that's where we're going to see this graph. A little different. So we know what this exponential graph looks like, right? Just kind of goes up like this. But we want to see this between, so from x perspective, bigger than -1, less than 3. So if we're here at -1, here's 3. We know the graph looks like this, We only want to see it from here to there, and that's it. Just that little section. Okay? So kind of the same thing. Let's go ahead and find where we need to put our pencil down for this one and where we need to end over here. Okay, so let me draw our graph. So -1, 1, 2, 3. So we want to see it right in that window right there. All right, so f of -1. And then also f of 3. So -1. F of -1. We plug -1 in there, we get 2 to the -1 minus 3. Do you guys remember what 2 to the -1? You kind of flip it. So this is actually what? 1/2. Good. Because that's 2 to the first, but that 2 to the first should be down below, so it's 1 over 2 to the first. Yeah, so that's 1/2 minus 3. Some of us can do that in our heads. What's 1/2 minus 3? -2.5. -2.5. Okay. So -2 and 1/2. Okay. So there's that. If that did make sense, real easy. You have 1/2 minus just common denominator. Right? Common denominator is 2. So multiply that by 2, multiply that by 2. So that's 6 halves. So 1/2 minus 3. 1/2 minus 3, 6 halves. So that's -5 halves. Well, what's -5 over 2? -2.5, same thing. Okay. All right, so there's that point. And then f of 3. This other endpoint, f of 3. Okay, so let's plug that in. And 2 to the third is 2 times 2 times 2, 8. Minus 3 is 5. So 5. Okay, so let's plot these. So we have -1, let's see, -1, 2, 3. So put -1, -2.5, which is right about there, close circle, right? Because when it's greater or equal to -1. And then 3, 5, 1, 2, 3, 4, 5. There's 5. This is an open circle, because when it's just less than 3. So this is actually kind of easier when you have 2 endpoints, because we're just going to connect the dots. It's going to connect the dots. So it looks something like this, right? Well, we just want part of it like that, and there it is. There it is. Okay? So domain range. Okay, so the domain's what? -1 all the way to 3. Okay, now what's our range of heights? What's the lowest? Yeah, -2.5. -2.5. What's the highest? 5. and then curved. There you go. Good. Okay, almost done here. Okay, number 5. Okay, let's say we have y or f of x equals 3. F of x equals 3. That's the same as y, right? Y equals 3. We all know what y equals 3 looks like. What does y equals 3 look like? This way or this way? Okay, half of you going up and down, half of you. Which way is it? Which? This way. Okay, well, I've seen some going like this, and so okay, this is horizontal. Y equals so y equals 3. This is okay. All right, so this is horizontal. So this should be easy. We just want to see a horizontal line, but part of it. And so let's just graph f of x if it's between 1 and 5, like that. Between 1 and 5. That's where we want to see this horizontal line. All right, so this one should be pretty easy. There's 1, 2, 3, 4, 5. Let's look at it. Actually, the homework will be just like this as well. So f of 1, f of 5. This prompts it and makes it a lot easier to graph. Well, f of 1. Okay, so f of 1. Is there any x to plug it into? No, but what's y? It's always 3. So I don't care what x is. X can be anything, but it's 3. If x is 5, y is 3. Let's plot those. So 1, 3, 1, 1, 2, 3. All right, so actually you plot it. Whether it's an open circle, closed circle, you draw the graph. Finish this off. Finish this off. There's about 3 moments. Okay, so finish the graph. Okay, so actually, Ethan, what do we do here? So okay, so 1, plug in 1, we got 3. So 1, 3, and then open circle, there it is, and then 5, 3. Is that open or closed? Closed circle, there we go, perfect. And then we connect the dots. Well, what do we connect the dot with? Is it a curve, or is it a line, or is it it's a line. It's a horizontal line. That's it. That's the part of the y equals 3 is everywhere. It goes all the way, but we just want to see that section right there. There we go. And then actually, what is the domain of this? 1 to 5. Like that. Right? Doesn't include, includes. And then what's the range of heights? 3. How do I write that? Just 3. Well, I'm just going to put there's one value, one height, y equals 3. Like that. Okay, you don't have to put any brackets or anything. There it is. Okay, last one. Whew. Okay, 6. Okay, let's do an absolute value of v. F of x equals absolute value of x minus 1. Okay, we're going to graph a section of this v. So you're going to graph f of x if x does not equal 2. That's where we want to see it. Everywhere. But x doesn't equal 2. Okay. If x doesn't equal 2, we want to see it. So we want to see this when x equals 3, 4. Basically, we want to see this everywhere except for 2, for x equals 2. We want to see the graph everywhere but x equals 2. So let's find f of 2, which we can do pretty easily. Plug in 2, and what do we get? 1. 2 minus 1 is 1. Absolute value 1 is 1. So at 2 comma 1, let's see what happens here. So 1, 2, comma 1. For graph it, we can somewhat accurately graph. If I did none of this and told everyone in here to sketch this V, would we be able to sketch this V, absolute value? Yes, because we do what? We go, where's the vertex? Which way do we go? Left or right? Right 1. Do we go up and down? No. So we just go right 1. That's our vertex. So we go right 1. Okay, so we go right 1. There's our vertex. Does the V open up or down? How do we know? Because it's positive, right? It's positive 1. So how do we do a V? What do we do now to graph it? There you go. Use a slope, right? So 1, up 1 over 1, 1 over 1, up 1 over 1. And actually, right at 2 comma 1, there's nothing there because we don't want to see. It's when x doesn't equal 2, everywhere else. So this is actually, there's nothing there. Up 1 over 1, up 1 over 1. So it goes like this. It's a V. You can even go up and back 1, but it goes like this. There's our V, which we can all graph. But right at 2, there's nothing there. So there's our V. Nothing's there. And then just last thing, domain range. Domain is a little trickier, but I think we can get this. So someone want to take a guess at how we write the domain interval notation? So, okay, so negative infinity to 2. Is that right? Square bracket? Is there, okay, curved. Okay. Okay, there you go. Union. Okay, because we don't want to include 2. Union from 2 to infinity. There you go. There's our domain. Range of good. Range of heights goes from 0 to infinity. What about 1? Is there a height of 1? Sure, it's over there. So it goes through everything. Lowest is 0, highest is infinity. Keeps on going. There we go. Okay, so I know it's easy to see, easy to hear me do it. Oh, I understand it. On your own, it's a little different story. So that's why we're going to practice right now. And okay, so in your packet, let's start this. I'll come around, help. So we'll work on this. We'll probably get a lot of it done, most of it done. We'll kind of see. I'll leave some time to review for the quiz, kind of go over some stuff, and then we'll take the quiz. And that'll be the day. All right, so get started on that.